So in this car, the velocity of the car relative to the truck is 40 meters per second. Don't forget your east, because car velocity is a vector quantity. It continues to say the vehicles collide. So they are in a car accident, in a head-on, and stick together during the collision. So the minute they say head-on, we know that it was from opposite direction. So that's some terminology. If they said bumper to bumper, you know that one was moving in that side, one just hits it from the back. But a head-on collision in opposite directions, so one velocity must be a positive and the other velocity must be a negative. And then they continue to say they have a head-on collision and then they move together as one. So most momentum questions that you can be told that they bump each other, then move apart. You must calculate the velocity of the other one. But in this case, they actually stick together as one. Now we know when they move together as one, that it means that our whole entire formula kind of changes. But before they want any further calculations, they say we must state the principle of conservation of linear momentum in words. So let's just state this one, the definition. So the total linear momentum remains constant in an isolated system. Now, my darlings, I know it is only for 2 marks, but you cannot fail definitions or principles or laws because you're lazy to read. If give or take, if a paper's out of 150 and you count all these 2s and 3s, the definitions and all that stuff, you can actually get away with 20 marks. That's already 20 out of 150 for just memorizing words. You cannot fail definitions because you are lazy to read. So trust me, if you know this off by heart, sometimes it might not even be out of 2, but in this case it was, but you cannot fail definitions. So let's see what the next question says. It says we must calculate the velocity. So they want the velocity of the truck-car system. Now, as you can see, they wrote car-truck system, meaning together, because they did say after the collision, they did move together as one. Initially, it was just a head-on, then they moved together as one. So we must calculate that velocity. Now, this is for 6 marks. But now remember, when you calculate velocity, you need a formula. I'm going to use a sigma, and it's pi, so total momentum before is total momentum after. So now you can write, I'm just going to write the one, total momentum before. I know some educators write it like this. If you prefer writing total momentum after is equal to total momentum before, you are more than welcome to write that. The examiner will give you a mark for either or. Now let's break it up. So initially, I have the mass of the car. Oh, let me just make that a small c. I've got the mass and the velocity of the car initial, plus I've got the mass and the velocity of the truck initial equal. They did say they moved together as one, so that is the mass of the car plus the mass of the truck. Now remember, when 2 things are moving together, it means that they have the same velocity, so that's the same VF. Now I just substitute everything as I'm given. The mass of the car was given to me as m, whereas the velocity of the car was 20, plus the mass of the truck was given to me as 2m, where the velocity was also 20. This is a negative. Remember, I took to the left as a negative, I took to the right as a positive. The car is moving to the right, so the 20 is a positive. The truck is moving to the left, so which means my velocity will then be a negative, is all equal to. I'm going to just substitute as given. The mass of the car was m, the mass of the truck was 2m, and then I must find my VF. I'm just going to solve that. I am going to do it the long way around so everyone knows what I'm doing. M times 20 will give me 20m. This is now just mathematics. 2m multiplied by negative 20 will give me negative. Remember, 2 times 20 will give me 40. Give me 40m is equal to, now I'm just going to substitute this. Remember, like terms from grade 9, we learned about like terms. M plus 2m will give me 3m. Give me 3m. Let me just put this one in brackets, VF. I'm just going to solve this one. 20 minus 40, that will give me a negative. This will give me negative 20m will give me 3m and then VF. So now, just to make things easy, I'm going to divide both sides by m because it is a constant on both sides. I'm just going to continue working there. If I divide both sides by m, I'm going to have negative 20 left on this side. I'm going to have the 3 and the VF. Remember, it's multiplied because it is next to each other. Now I just need to find VF by itself. So I divide both sides with what's bothering VF. In this case, it is 3. Divide both sides. This and this will cancel. I'm going to have VF on this side. Let's calculate how much do I get there. I love putting it exactly as it is, 20 over 3. This will give me 6,67. Remember, it must be to 2 decimal places. The third number is greater than 5, so I'll change my number to a 7. Remember, it is a negative, so that's negative 6,67 meters per second. Now remember, I did take to the left as a negative. Let me just double check what the story says. So if this is east, then this must be west. Remember what we said about the lingo. I can't say to the right, to the left, I must say to the west because that's the lingo we're using. In mathematics, a negative just means direction. Velocity is a vector quantity. You remove the negative by giving it the direction indicated on the scale. So this will be 6,67 meters per second to the west. To the west. I just want to elaborate a little bit more. So this means during the head-on collision between the car and the truck, as they bumped each other, the truck, could say it's a little bit bigger than the car, so it actually moved in the direction of the truck. So I can see that to say that because my answer is a negative. I've seen a question before that said, prove that the truck car system moved in the original direction of the truck. Now we can prove that because my answer is a negative. I did choose to the west as a negative, so it means that it did move in the direction in which the truck was still going. And that was for 6 marks. So don't forget your direction because velocity is a vector quantity. So for number 4.4, we are therefore told on impact, so as the cars collide with each other, on impact, the car exerts a force of magnitude F on the truck, and the truck experiences an acceleration of magnitude A. Now already we can see F and A, there's a relationship there, F is equal to MA. And we get this, I just want to make this A is equal to F over M. Now this is what we learned from Newton's second law. So already I can see there's a relationship in terms of mass and acceleration, and I can see that there's a relationship between acceleration and force, where acceleration is directly proportional to the force but inversely proportional to the mass. So I'm just going to put this there because seemingly when I'm reading the statement we are going to need it. Number 4.4.1 says we must determine in terms of F, so only in terms of F, you don't have to make a calculation, the magnitude of the force that the truck exerts on the car on impact, and we must give a reason for our answer. I just want to go back here. So they did say the car exerts a magnitude of F on the truck. Then they're asking us, but then what will the truck give, what impact or what force will the truck actually give to the car? You can see that it only is for 2 marks. That's the first hint. The second hint, it says, give a reason for your answer. They didn't say show by calculation. This means we need to use a theory or a principle or a law. Now I want you to think carefully. I've got 2 objects moving in opposite directions and then they collide with each other. According to physics, it says if object A exerts a force on object B will exert an equal but opposite force to object A. So if the car is coming with a force of F towards the truck is also coming with a force of F, but just in the opposite direction. We've proved the opposite direction because I did take to the east as a positive and I did take to the west as a negative. So we must give a reason. So first things first, we must determine it in terms of F. So the magnitude that the truck exerts on the car, it is also F, because I was told that the car gives a force of F on the car. And it says, give a reason for your answer. So we can say we can use Newton's third law. Newton's third law. Newton's third law of motion. So we can use Newton's third law of motion to understand this, to understand or to explain. But this is definitely Newton's third law. If they did say, please state the law or the principle that we could have used, then we could have stated the whole principle and the law. It was only for 2 marks, so it means that all your information was on the statement that you were given. You just had to recall what we learned in grade 11 of the different types of Newton's laws, and this was actually one of them. The hint is they are in opposite directions. Let's look at the next one. Now we're on 4.4.2. And it says we must determine in terms of A. Now we're talking about acceleration. Let's go back. This is the one that I have for acceleration. Remember, acceleration directly proportional to my force, but inversely proportional to my mass. This means if my acceleration increases, my force will increase. If my acceleration increases, then my mass will decrease because they are the other way around, inversely proportional. So we must determine in terms of A, the acceleration that the truck experiences on impact. And then we must also give a reason for my answer. Now remember, where do we get A? I'm going to start it. We have a formula F is equal to ma, but we need to show the relationship that of the acceleration that the truck will experience. So I'm going to say A is equal to F over m. So this means that the truck will experience half of that. So A for the truck will be half of that. How do I know this? Remember what they said. The car has a mass of m, where the truck has the mass of 2m. So the acceleration will be a half of that will be experienced by the car because the truck has a greater mass than that of the car. So that one was also pretty easy. This was for 2 marks. So the next question says, both drivers are wearing seat belts. Which driver is likely to be more severely injured on impact? Explain by referring to the acceleration and the velocity. So now I want you to think of this pretty logically. Now we've got 2 objects that are moving in opposite directions. The speed of the objects is exactly the same. They were both moving at 20 meters per second. And then we have a small object, then we have an object that is twice the size of this object, and then they collide. It's like fighting with a bully. You know, if I'm going to fight with a bully who's twice my weight, twice my height, twice my speed, obviously the little person's going to get hurt. So because the truck is twice as big as that of the car, then the car driver is going to get hurt a little bit more because he's a little bit smaller. But now we have to give a reason because it does say it is for 3 marks. So first things first, we must say which one should be more injured because you do get a mark. So my first assumption, I'm going to tell the examiner, the car driver. The car driver will be more hurt. Now, let's give a reason for 3 marks. He will have a greater acceleration. Why is my pen not working? Okay, there we are. He will have a greater acceleration. Now, I just want to go back to this one. Remember, when we talked about the acceleration of the truck, it was half of because the mass was twice as that of the car. So the car will have a greater acceleration, and then which means if there is acceleration, it means that there is a change in velocity. So the car will have a greater change in velocity. The car driver will have a greater change in velocity. Now I want to just take this statement here quickly. Remember, acceleration is equal to Vf minus Vi all over change in t. Now I want to just elaborate this a little bit more so you kind of get the picture in your head. You are traveling in that car, and then after the collision, you move in the direction of that truck, right? The truck technically was just slowing down, but it didn't change direction. As a car driver, you were moving to the east. In a collision, now you're moving to the west. A change in velocity means acceleration exists. And remember, it was in a space of time where you were traveling and then you had to change back because you were in a car accident. So this does prove that the car driver will have a greater change in velocity because the truck was moving to the west, and after the collision, it continued moving to the west, probably in a slower velocity, but it actually continued moving in the direction which it was originally moving in. But I think the trickiest part for this question over here was to calculate the velocity of the two, because they did want a number, but the whole trick was like terms is what we learned in mathematics, and m could have cancelled out because it is then therefore a constant in this question. But nonetheless, it's actually a very nice momentum question, but you must look at the nitty-gritties and the terminology that they keep using, and you should actually be able to answer any momentum question. So nonetheless, I will see you on the flip side when we get back from the ad break.
No one ever asks why we do the weird things we do. Like, why once is never enough. Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings. At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Did you know there is a bright bubblegum pink-coloured lake on an island off the coast of Australia? Lake Hillier is found on Middle Island off the coast of Australia and is about 600 metres in length. But by far its most interesting attribute is that the lake appears to be a solid and bright bubblegum pink when viewed from above. No one knows exactly why this is, but scientists speculate that the colour comes from a dye-producing bacteria.
Welcome back from the ad break. Thank you so much for still staying tuned in with me. I am Tobile, and you are watching Tenfold Live. So I want to send tons and tons of love once again to Liberty. Thank you so much for giving us the opportunity as well as the platform to actually helping the class of 2021. And grade 12s, if you haven't done it yet, please do download the Tenfold Education app. It is an app filled with tons and tons of past papers that can help you guys prepare for your final NCS. I know you guys are writing mathematics on Friday, so it is an app that can actually really help you prepare. If you're wondering where we got the question papers or you'd like to join into the fun, please do send a hi on the WhatsApp number on the screen, and you'll be able to join me in answering the rest of these questions. Another platform where we are actually live and active is on YouTube, and there we are then Mindset Learn. So in today's show, we're doing all about revision. I know physics paper 1 is soon on the way for the prelims. All the best for that. So I am doing questions which are in line with question paper number 1 for physical sciences. The previous question, I did a little bit of momentum. So now we're going to do a little bit of work, energy, and power. Now, I know that is a topic that most of you guys shy away from. It is actually very easy, but I'm going to show you the nitty-gritties on how you need to answer it. So this question comes from Pumla Ntlapo. And Pumla says, Tobile, my dog, please help me. So this question says we have a pendulum with a bob. Bob just means this circle thing. A bob with a mass of 5 kilograms. What I always teach my kids, as you are reading the equation, write down all the information that you have. If you're feeling like you are losing your mind, is held stationary. Something is stationary, which we've learned in grade 10. It means that the velocity is 0 at a height of h meters. So again, they're just using alphabets. h meters above the ground when released. So remember, if you're holding a bob there, a pendulum, and then you decide to let it go, it's obviously going to swing. So initially it was at 0, and if something starts moving, then it has velocity. Just going to go back to, remember, if we talk about work energy and power. If something is at a certain height, there's a certain type of energy that it possesses, and then it starts moving, and then there's another type of energy that it possesses. So already keep that lingering in your mind. When released, it collides with a block. Okay, so it's hitting something, collides with a block with mass 2 kilograms, which is also stationary at point A. Remember, if something is stationary, it means that the initial velocity of that object is then 0. The bob swings past A and comes to rest momentarily at a position a quarter of that of H above the ground. I just want to go back to this. They did say initially it was at a height of H. So whatever H is, it rests at a mass of a quarter of that. So if we could find H, we could take a quarter of that to find this one. And so the diagram is not drawn to scale, and this is what's happening, and I can see that the block is moving in this direction. I know that because this is a vector. Remember, we show vectors in physics with an arrow, and it's pointing in that direction. So immediately after the collision, the 2 kilogram block begins to move from A, which was at rest, to B, wherever B is, at a constant speed of 4.95 meters per second to the exponent -1. I know that speed is constant, or constant velocity, then acceleration is therefore 0. So that's me looking and analyzing my entire diagram. So let's see, what do we have? So the first question says we need to calculate. It says we must calculate the kinetic energy of the block immediately after the collision. So first things first, remember EK, you do get a mark for the formula, is a half mv squared. Now they did tell us that after the collision, what speed is it moving in? Now the tricky part with this was we were not told what speed the bob is actually moving in. The only thing we are told, now I want you to think about this logically. I have a block that's not moving, and then I've got a pendulum that swings, and it hits the block with such a velocity that the block actually moves with 4.9 meters per second, right? Which actually makes sense, which means whatever velocity that this block was, it actually transferred it to this block, and then it continues to move. So that's the one way that we can do it, to calculate the velocity of the block immediately after the collision. So I'm going to say it's a half. The mass of the bob was given to me as 2 kilograms. The block was given to me of 2 kilograms. And then the velocity of the block was 4.95, and that is squared. Oopsie daisy. There's my calculator. That looks more familiar. 0.5, I've got a mass of 2, and then 4.95 to the exponent 2. Now remember, don't forget your SI unit. So I do get 24.50. 4.50. The SI unit for kinetic energy is therefore in joules. So that one was pretty easy. Now we need to calculate the height, which is therefore h. Just want to go back here. Now we know I've got two h's. The one is just h. The one is a quarter of whatever h was. But the question wants the value of h. Now I'm going to do it using mechanical energy. And why am I using mechanical energy? I want to start it from the beginning. Remember, I've got a bob at a certain height. If something has got height, it's got potential energy. Now remember, in energy cannot be created or destroyed, but it's able to be changed from one form to another. So as this bob is sitting here, and then it's being released, and it starts to swing, it now possesses kinetic energy. It hits the block, and it continues to move, and rests momentarily at a height of a quarter of that, what h was. So this means I actually am working with potential energy and kinetic energy, but I'm working with potential energy before and after. So before the collision, there's potential and kinetic. It hits the block, then there's kinetic, and then there's potential because it's at a certain height. So exactly just like the formula for momentum, I'm going to have to indicate, but in this case, it's mechanical energy. So I'm going to say Emech for mechanical energy, and this is before. So this is before it hits the block. And then I'm going to say Emech for mechanical energy, and that is therefore after. So now let's break it down. Remember, mechanical energy has two types of energy. We've got potential energy, which possesses height, kinetic energy, a half mv squared, which is motion. After also has potential energy, which is mgh, plus I also have kinetic energy, which is a half mv squared. Now I need to plug in everything that I'm given. Remember, I do have a mass of 5 for the bob. They did say the bob has a mass of 5. So I'm going to put in the mass of the mechanical energy, it's 5. Remember, it was at a certain height that we don't know, but the gravitational acceleration at any height is 9,8, and I don't have h. Plus, now remember, they did say this bob was there and it was stationary. If something is stationary, if something is motionless, or something is standing still, then the velocity is 0. Now I want you to look at this formula. If I substitute v with 0, anything multiplied by 0 remains 0, even if you can square it to 1,000,000. So this will be 0. So the kinetic energy is 0 because the bob is stationary. It's just being held at that position. And then I am told, now this is after the collision, the bob's mass didn't change, it remains 5. And then the gravitational acceleration is still 9,8, but now what did they say? It rests momentarily at a height of a quarter of that of what h was. Just want to go back and show you where I'm getting that. So this is before the collision, and that height was h. And then after the collision, after it collided with the block, it rested at a height of a quarter of that of h. So I just substitute what I'm given. They told me the height was 1/4, which is a quarter of h. You substitute it exactly as it is. Now, the velocity of that, I'm going to take the velocity of this one over here, the kinetic energy, which is 24.50, 24,50. You can calculate it if you wanted to, but we've already calculated, so that's not such a train smash. So now I'm just going to work this out. So the rest of this is just mathematics. So let's do it step by step. If I say 5 multiplied by 9.8, then I get 49. Remember, it's 5 times 9.8 times h, which is therefore 49,9h. I'm going to work this one out. So I'm going to also put it in exactly as it is. I've got 5. I must multiply that with 9.8. And therefore, I also have 1/4. Let me see what I get there. Therefore, I get 12,25. Remember, it's 5 times 9.8 times a quarter times h. And that is then how I get 12,25h plus the 24,50. Now, this is just mathematics. Remember, in mathematics, we're always told to move all your unknowns to the left-hand side, move all your other numbers to the right-hand side. That's how I teach my kids. Because we're looking for h, I'm going to move everything to the left-hand side, all other numbers to the right-hand side. If any variable jumps the equation sign, the sign will change. I should stop saying jump. I think Spusiso will start killing me. It's not jump. It doesn't jump. It just, physics teachers, we like saying things like that, but it doesn't really jump. But now if this 12 comes to this side of the equation sign, it becomes a negative, and that is equal to 24,50. And as you can see, I only have one unknown. So just more mathematics. I'm going to say 49 minus 12,25, and that's how I get 3675h. Don't forget the h. 3675h is all equal to 24,50. Ooh, I think I'm running out of space. I just want to write this one here. So you've got 3675, and what I always tell my kids, and what is very important when we're in the marking center, is to always show all your steps. I know it is a bit long but it just makes it a little bit better. So I want the h. I'm going to divide both sides with what's bothering the h. In this case, it is 36,75. What you do on the one side, you do on the other side. This and this will cancel. Then I've got h. Then the last bit of mathematics. So therefore, I'm going to have 24.50 all over 3675. Let's see our value for h. Remember, it must be to 2 decimal places. If the third number is greater than 5, then it changes the number before it. In this case, we do have 6. So it changes the 6 in front of it into a 7. The SI unit for h, my darlings, is therefore then a capital It is a small letter m. Don't put a capital M. It is meters, which is just m, and that's how I calculated the height. I think I can see why Pumla might have had a bit of a problem with this one, because again, just like the momentum problem, we were only given variables. We were not given values. But now guys, if you're given variables, don't shy away from it. The minute they both h's, it means that somewhere, somehow you will have like terms, and then you are able then to solve it. Because most of the time, unlike in mathematics, we don't really do a lot of simultaneous equations except in Newton's laws. But more or less, if they give it to you like this, or like how they did in momentum, somewhere, somehow it has to cancel. So this is how we would have calculated the value of h. And then we've got a continuous question with this one, also in terms of work, energy, and power. And this one says the block moves from point B. So it starts off at point B. So initially, at B now is 4,95 meters per second to the exponent minus 1. I just want to go back to this one quickly. Remember what they said to us here, that initially, so this was the first phase of this block. Initially, the block was at 0. It was just standing there, and it was not moving. They did say it was stationary, so the velocity was 0. And then all of a sudden, it's been hit by a pendulum, and then the block starts moving. So initially, it has a velocity of 0, and then it moves to B, where now it has a final velocity of 4,95 meters per second. I just want to include this one here, where the initial velocity was 0 meters per second. But now they want us to continue with this block as its initial velocity at the 4,95. So it was first standing still, then it starts moving at 4.95, then that scenario is done. And then at 4.95, it's initially moving at the 4.95, and it starts going up a ramp. So we actually have like 4 stages for this poor block as it just continues to move. So I just want to draw a zigzag. Everything before this arrow, it's the whole pendulum and so forth. The final velocity after it was hit by the bulb was 4.95. Now, after, this becomes my initial velocity, the 4.95 that it received after being hit. So now it moves from B with an initial velocity of 4.95, and it moves up an inclined plane, and it moves all the way to point C. So this becomes my initial velocity. Whatever velocity that this block will have at C will be its final velocity. So now I just want to elaborate on something. If you maybe might be feeling that, oh my word, Torps, I think the velocity that I got at B or however is not right, or it's wrong, or however, just use whatever answer that you've gotten here. The examiner will see that you have continuously used the answer that's not really right, but in the correct place, and then you might just be awarded marks. So let's see, the speed of the block at point C is 2 meters. 2 meters to the exponent negative 1. The point C, so they've given us, is 0.5 meters above the horizontal. So they've given us the height of this ramp that it moves as shown in the diagram. During its motion from B to C, a uniform frictional force, dun, 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 something that I need to remember about frictional forces. If this block is moving in this direction, friction will always oppose motion. So the frictional force will be in the opposite direction that the block is moving. Because remember, friction says, no, you're not going there, and it slows down whatever option that we have. And I can already see that this ramp has like some zigzags on it, which is a representation that friction is then therefore present. So let's look at the question that they have. So now that's me analyzing the whole diagram. Now I've analyzed the entire diagram. Let me just add some space for me there. So it says, state the work energy theorem in words. Can you see another 2 marks? You cannot fail because you're lazy to read. So let's state the work energy theorem. This is one of the easiest, and it's one of the ones that they actually love asking. It is the total work done on an object is equal to the change in the object's kinetic energy. So the work energy theorem, it is the total work done on an object is equal to the change of the object's kinetic energy. Now, if you think about it, if you use the formula, I always love using formulas. Work net is equal to change in EK. So the total work done on an object is equal, remember a triangle in physics, we all call it delta, but it also means change in the object's kinetic energy, which is EK. So if you're kind of thinking you forgot it, use your formula like all other definitions, and therefore you should then get it right. But that is the definition for the work energy theorem. Now let's look at the next one. So the next question says, use energy principles. Use energy principles to calculate the work done. To calculate the work done by the frictional force. They did say, well, we do know that friction opposes motion. The frictional force when the 2 kilogram block moves from B to C. And remember, this is therefore it's going up a ramp. So you can work, so there's various ways that you could have done it. They did say energy principles, so you can work with conservative or non-conservative forces. Remember, some of them are path dependent, others are not path dependent. Other energy principles, you could have worked with kinetic energy as well as potential energy. It is moving on a flat surface, it goes up a ramp, so you could have used one of the two. It is for 4 marks, so please show the examiner exactly what you're doing step by step. So I'm going to say, I'm going to work with non-conservative forces. Remember, the work done by non-conservative forces is depending on the initial and final position. EK, I'm trying to multitask, and the change in EP. Final position, but also on the path between them. That's my non-conservative forces. It's equal to the change in kinetic energy plus the change in potential energy. Now remember, the minute you have the word change, you must then have final minus initial. Think about velocity or the formula for acceleration. Acceleration is VF minus VI all over delta, change in time. So as well as kinetic and potential, you're going to have a change where you have the final minus initial. So keep that in mind. So when we have our non-conservative forces, in this case, it is my frictional force. So it is the work done by my frictional force. They did say work done by frictional force, not just the frictional force. So now I'm going to break my kinetic energy. For me, it's just easier to say a half. The mass doesn't change. However, when something is in motion, then the velocity changes. Then I can therefore say VF squared minus VI squared because the velocity changes. Plus, when something has potential energy, the mass stays the same, gravitational acceleration stays the same, however, the height will change. This means I've got HF minus HI because, for example, with this one, it is moving at 4.95 meters per second on B, and then it starts going up a ramp on C, but by the time it reaches C, it's only moving at 2 meters per second, right? That's the first change in velocity. That's the kinetic energy. Let's go back to B. As it moves from B, it's moving, it's on the surface, and then it starts moving, then it goes up a ramp, and the ramp that we were told that is 0.5 meters above the horizontal. So again, as you can see, there is a change in height from 0 all the way to 0.5, where with velocity we've changed from 4.95 all the way to 2 meters per second. Again, there's a change. So for me, it's just easier to do it like this. You can do it the long way around, have various brackets if you wish, that's all well. Now I just substitute and plug in. This is a half. The mass of the block didn't change, it's still 2. The final velocity of this block, I was told, is 2 meters per second. I use it exactly as it is. Now remember, this block did not change direction, so no vectors in opposite directions. Initially, it was moving at 4.95, and that is squared. Let me just do that the proper way. Let me not try to squeeze it in. There we are, plus the mass of the block is 2. Gravitational acceleration is 9.8, and then we know that the height changed. The final height at point C was 0.5, but initially it was on the ground or on the surface, which was then for 0. So I'm just going to plug in everything as it is. You can do it step by step. I'm going to attempt to fit it all in. Let me just move this over here. And I like using brackets with everything. 0.5 for a half. The mass is 2. That is 2 squared minus 4, backspace 4.95, and that is squared. Let's bring down my bracket plus. and this is 2. My gravitational acceleration is 9.8. Let me just close this one, and then I've got 0,5. Don't really have to put the 0, but just to be on the safe side. So therefore, I get my height as 10, negative 10,07. And there we are. So here I get negative 10,70. And remember, the work done by friction is therefore in joules. I just want to elaborate a little bit again here. Remember, when we talk about forces, the block was, we can actually say that the bob actually had exerted a force on the block, and then the block started to move in a certain direction. And as it was moving, it was moving at 4.95, then it started moving on this wobbly, bumpy road, on this incline, and then its velocity started slowing down because friction is opposing the motion of the block. Friction works in the opposite direction. If there's 2 vectors in opposite direction, one must be a positive, one must be a negative. If the block is moving in this direction, friction is opposing it, friction must be a negative. So I can see that the work done by friction is a negative answer. I've got negative 10,70, which actually does prove that my answer can actually be right because it is a negative, and friction opposes motion at all times. And that was then how I would have answered this question. So that was our last question from this one. Let's look at another one. So, okay, I'm not sure which learner had this question for us. Let me just see here quickly. Okay, so the producer just told me there's no learner for this one. So let's see. This is question number 9, and this is also about impulse, force, and momentum. So now another definition. So already, out of the questions that we did, we already have 6 marks for just the definition. And now we are told we need to define the term impulse. So let's start. Impulse, it is the product. It is the product of the resultant force acting on an object and the time the resultant force acts on the object. So when we define the term impulse, it is the product of the resultant force acting on an object and the time the resultant force acts on an object. Just want to drag this a little further. So remember, we do have the formula F net delta T is equal to delta P. So we say F net, if we make F net the subject of the formula, we have delta P all over delta T. So like I always say, guys, if you kind of sort of forgetting what your definition is, go back to your formula, and your formula will actually then tell you the definition. I want to give you a little secret. When I was in grade 12, I used all my formulas for all my definitions. Make sure that you get full marks for all your definitions. It's really easy marks. So we've defined that. Let's look at the next statement. So here we are told, that the gun is capable of firing bullets rapidly. So if something means rapidly, it means that you don't have to, I'm not really sure how guns work, but for me, if we talk about rapidly, it means that you don't have to shoot and then load your gun again and then shoot and then load your gun again. So you can go do, 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 do. That's rapidly. So it's one after each other, right? Meaning that the time interval between them will be exactly the same because you don't have to reload your gun the entire time. So rapidly in a horizontal direction, each bullet travels at a speed of 700 meters per second in an easterly direction. Do you see the lingo again? They're not talking about left or right, they're talking east and west. And here they've given us a little compass. In an easterly direction when it leaves the gun. So already I must think about something here when something leaves the gun. Because here I'm told that take the initial, remember initial is the starting velocity of a bullet before it is fired as being 0. Which makes sense, because if you load guns in a bullet, the bullets are kind of sitting inside there waiting to be fired. Remember, if something is stationary, if something is standing still, or if something is motionless, then the velocity is 0. So as they're sitting there, and then they get fired rapidly, and then they have a velocity of 700 meters per second. Initially, they'll add 0, and then the final velocity that the bullet will have will be 700 meters per second. So already keep that in mind. There's already a change in velocity. So I can see the gun there, which is this motion here. I can see the mechanical support, and I can see the bullets that are being fired. And as you can see, it's one after each other. So that is in rapid motion. So the gun fires 220 bullets per minute already. I know that when we talk about time in physics, we talk seconds. So in 60 seconds, the bullet can fire 220 bullets. And the mass of each bullet is 0.03 kilograms, which is nice because they've already given it to me in the correct SI unit, so there's nothing for me to convert. So let's see what they want. There's a lot of information. Now, as you're reading the statement, you can already see that they can ask these questions in any direction. So in 9.2.1, they say calculate the magnitude. Remember, magnitude is just a fancy word of saying size. Calculate the magnitude of the momentum of each bullet when it leaves the gun. So this is very easy. This is number 3. They just want the momentum of the bullet. They don't say the change in momentum or anything. So momentum is a product of an object's mass and velocity. Remember, it is a small p. The mass of each bullet, we were told, is 0.03. The velocity of each bullet, because they did say when it leaves the gun. Remember, they did say when the bullets leave the gun, they leave at 700 meters per second. Well, if they did want the momentum of the bullet when it was still inside the gun, then that would be 0, because the velocity is 0. But that is 700. So this one is an easy one. So that's 0.03. Multiply that by 700. So I therefore get 21. So the momentum will be 21. Remember, the SI unit for momentum is kg, because there's mass, dot. Then there's meters per second, because then we've got velocity. And therefore, there it is. That's just for 3 marks. This is a very easy one. Very rare to find a question this easy, actually. And then let's look at 9.2. So with 9.2, they're asking me to calculate the net average force that each bullet exerts on the gun. So now we know that the bullet is going to have a change in momentum, because initially the velocity was 0, then they get fired out, and that's the momentum we just calculated. We do know that the bullets are going to leave the gun at an interval or a certain amount of time. We now need to find the force that is actually exerted. And I can see that is for 5 marks. So I think first things first, because I just want to go back to my formula over here to show you why I need this. Oh, I erased it. The F net is equal to delta P over delta T. They do ask about force, which means I need time. The only form of time that they told me is that 200 bullets are emitted in 60 seconds. So that means I need to find the speed or the time interval for 1 bullet. So I'm going to work here because it's quite a lot. Time, so this is the time for the bullet. So I'm going to show you how I calculate the time. So in 60 seconds, I want to know how many bullets can I actually fire. It's not the other way around. What I always tell my maths literacy kids, you must be careful. When do you divide and when do you multiply? In this case, I've got a time of 60 seconds, and I need to know if 200 bullets are being emitted in 60 seconds, how fast is 1 bullet actually moving? So I've got the 60, the 220 at the bottom. So let's find the time of the bullet. So I'm going to have 60 at the top. The bottom, I'm going to have 220. So I've got 0, oopsie daisy. I've got 0.27. The third number is a 2, so that doesn't really affect. 0.27. And remember, the SI unit for time is seconds. So I can say, therefore, say F net, they do want the average force, is equal to change in P final minus change in P initial. Well, let me just write it like this to be on the safe side. MVF minus MVI all over delta T. Remember, I do have my final momentum there, which is the 21. You don't have to calculate it again, but if you do calculate it, it's not a train smash, but we've already calculated it. The initial velocity, remember, initially it was not moving inside the gun, so that's why my initial momentum is 0. I just calculated my time to find that it's 0.27. So now let me calculate that so that I can find out what is my average force. So at the top, I've got 21. I'm not going to put the 0, and that is 0.27. Therefore, I get 77.78. 77.78. And the SI unit for force is then newtons. Another way you could have written it or could have attacked this question was to find the change in momentum. So I could have found the change in momentum, which could have been mv. Now remember, I could have used this momentum over here. Let me do it the long way around so that everyone knows where I'm coming from. Remember, we have F net. F net is equal to delta P all over delta T. I'm going to find the change in momentum first. So I'm going to do this by saying that delta P is equal then to, remember I found my momentum over here as 21. So each bullet is going to leave with a momentum of 21. And also at 60 seconds, I'm able to fire 220 bullets. So I'm going to have 220 bullets. Then I'm going to find the change in momentum for everything. Once I find that, then I can divide it by the average force. So if I say 21 multiplied by 220, and then I got 4620. So this is 4620. Just want to work here. Now I can say that the average force that I have is my momentum over my time, which is my 4620 over a time of 60 seconds for all the bullets. I know that collectively the bullets are 200, but the time will then be 60. So if I take this answer and divide it by 60, I again get 77. 77. The SI unit for force is therefore then in newtons. So that's another way you could have tackled it. I like the orange method a little bit more. It's less complicated. But either way, I mean, you could probably have also used VF is equal to VI plus A delta T. So there's various ways you could have actually done it. I only tried it with these two though. So number 9.3 says, without any further calculation, so now they want to see if you understand and know the laws of physics, write down the net average horizontal force that the mechanical support exerts on the gun. So now think about it. The gun is sitting somewhere, and then as the gun fires, the mechanical support also moves. It moves as well. So this means, they did say without further calculations, it means that it will also be 77.78, and this will be to the east. To the east. I just want to go back up here. They did say that the bullets are being fired to the east. And then we've got the mechanical support that will also move to the east. Remember, it's like a, I've never really shot a gun, but the recoil and stuff that the mechanical support exerts on the gun, it will move in that direction also to the east, and that was therefore for 2 marks. So this was not a difficult question, but I think just moving from the time of how fast is one bullet moving and all of that things, after you've actually figured all of that out, then more or less it should not be that difficult. But thank you so much for all the questions that came through. It really makes me feel so good to know you guys are working hard, and it makes us feel so especially at Mindset to know that we can help you. Nonetheless, I will see you next week.
What's up, peeps? Welcome to Moby School. We are here to make sure that you, yes, you get all the marks that you deserve on the go. We're here every Mondays to Fridays from 2 to 3 p.m. only on Mindset Learn TV. Now, this is a whole hour worth of revision just for you. And I hope that you've got your notepads and your pens ready and that you and your study group are game for today's revision session. Now, my name is Joe, and just like you, I'm also in Matric, and I'm here for a whole hour to make sure that I ace my final exams. And I hope that you will be doing the exact same thing. Now, do remember that we love hearing from you guys. So log on to our Facebook page, which is www